Welcome back, everyone, to the 102 stream. I hope you had a good first day of the conference yesterday, day two today. And we've got Jay Carino from IBM with us today. And she's going to be talking about Galasa testing on the mainframe without knowing the mainframe. As always, with the other sessions, if you've got any questions at all, at any point, just pop them in the chat. And Jade will take the questions at the end. She's got a dedicated time for that. So I will hand it over to Jade. Thank you.
Great, thanks, Lewis. So yeah, hi everyone, I'm Jade. I work for IBM and I'm a software developer on the Galasa open source project. Ooh, that's great. Okay, so I think just a quick agenda for what I'm hoping everyone will get from today's session. So I'm going to be speaking quite a lot about integration testing on the mainframe and how that can be challenging, especially when you are a person that's new to the mainframe. So in this session, I'm going to show you how to use Galasa, which is an open source solution built by IBMers like myself that helps make integration testing on the mainframe possible. So before we get into the content, I just wanted to discuss the different types of testing that to kind of get you thinking about the types of testing that you might already have in your organization or the types of testing that you would like to implement. So commonly, you might already have unit tests that are built in your code and run as part of your build pipeline. So while this is useful, unit tests do have their limitations, especially when testing a larger application, which some mainframe applications can be. Obviously, you can't test middleware or OS configuration with unit tests as well. So starting to go higher up the triangle, now people can have obviously different names for these, but these are largely kind of called integration testing and then system testing. Integration testing, of course, where we're talking about kind of combining those software components and testing them as a whole entity. So as I mentioned in the agenda slide, a lot of this presentation is going to be focused around that integration test level. We're going to be speaking about how you go about doing that in a hybrid ZOS application. So on the right here, we have a diagram representing sort of your typical architecture that you might have for a hybrid application. So you might have a web browser, which drives a web server, which is hosted on an on-premise or an off-premise cloud. That might drive a Kix application, which is sitting on a ZOS LPAR, and then that Kix application is then going to be speaking to some sort of database. So how do you go about testing all of these different components at the same time? How do you actually verify that the information that was passed from the system of engagement, the web browser, has actually made it all the way through and gone down to the system of record and been collected there? So integration testing an application like this can be difficult. As we can kind of see, there's a range of interconnected different platforms. You'd have to use a number of different test technologies to test all of these different parts. So you might need Selenium for the web browser, JMeter, you might need JCL and 3270 screens for the ZOS side of things. Even if you did know how to use all of these test technologies separately, to do an effective integration test, you'd have to execute them in the same context, which is what can be the challenging thing to do. So again, sort of some challenges here of testing a hybrid application, especially for someone that's maybe new to the mainframe. Of course, in the mainframe, there's about 60 years of kind of obscure legacy code. So it's really difficult to get your head around that, especially as, again, someone new to the mainframe, maybe an early professional that's joined a mainframe department. So, you know, not knowing where to start, not knowing exactly what test tooling that you can use. How do you test the integrated whole as well as the individual components of that application? Where do you get the resources for your test environment? You know, how do you write code that natively interacts with ZOS? You know, I haven't come across many people that know how to write Java, for example, that natively interacts with 3270 or ZOS byte streams, for example, and that's okay. How do you write JCL? How do I interact with the 3270 screen? How do I connect to a Kix application? These are all questions that you might have when you go about starting to test some of your applications. And the point of this presentation is that you don't really need to know in depth how you do those things. So you don't need to be an expert mainframer to be able to test on the mainframe. So for myself, for example, I only joined IBM less than 3 years ago as an apprentice. I had no technical experience or knowledge before that. So for me personally, I mean, I'm still not an expert mainframer. I actually probably would consider myself still new to the mainframe. And that's okay. When I first joined the Galasa open source project, one of my earliest pieces of work was actually to diagnose a test failure in a test that had code to do with ZOS datasets. And I didn't really have much knowledge of what that was, but the Galasa framework actually helped to make this easy for me to debug that and diagnose that. So I'm going to get into how they did that. So what is Galasa? So Galasa is an open source integration test framework developed by IBMers, and it's built with a knowledge of ZOS. And this enables you to do end-to-end testing of applications that run on the mainframe. And this is without stubbing or mocking. So through something called Galasa managers, which I'll speak about quite a lot in this presentation, Galasa is fully extensible. So Galasa can interact with any test technology through the Galasa managers. Galasa also provides a REST endpoint, so you can call Galasa from any CI/CD pipeline that you might have. And running Galasa is part of a pipeline enables really fast and reliable testing at scale. So Galasa can actually run thousands of tests in parallel. And also being open source, there is no vendor lock-in, so you can integrate Galasa with, like I say, any of your existing pipelines that you have, and also allow it to work with third-party tooling. There isn't any kind of restrictions on what you can and can't do. So what are these kind of Galasa managers that I've mentioned a couple of times? So Galasa tests, before I get into this, Galasa tests are sort of JUnit style Java test classes. Galasa is written predominantly in Java. So a Galasa manager would be a piece of Java code in which the complex logic that natively interacts with all of these kind of technologies you see on the screen, that's abstracted away from you, and that's written by an expert, and that's placed inside that manager. So anyone that wants to use that test technology in their testing can essentially inject that manager into their test and use sort of the utilities of that manager. So you don't need to know, as I mentioned previously, you don't need to know the ins and outs of how do you natively interact with these things, because that's all done for you in the manager, written by someone else and delivered as part of the Galasa product. So you can probably see on the screen, we've got, the ZOS manager, and we've got a whole host of things that come under that kind of umbrella. So this is really what allows people new to the mainframe to test ZOS applications like an expert would. So I'm not going to list all of these, obviously, but you can just see on the screen, I've taken this from our website. This is a list of all of the sort of mainframe related managers that we have. So obviously a lot of ZOS related things. We have a suite of Kix managers, MQ, all really useful stuff that you probably want to bring into your test if you're going to be testing on the mainframe. So what actually can you do with these managers? So I've just pulled out a few kind of really useful things that you can do with these that we've seen quite a lot of our customers doing in their tests, and what we've actually done in quite a lot of our tests as well. So what do these help you to do? So you can, using these managers, access and configure information about ZOS images and sysplexes. With ZOS batch jobs, you can submit, monitor, retrieve the output of those. You've got, ZOS console commands that you can issue and retrieve the responses from as part of your test. Manage and transfer files to and from ZOS. A really useful one, which I'm going to be showing in a demonstration a little bit later, is executing 3270 terminal interactions. Writing data to a TS queue, linking to a Kix program, all really, really useful things that you can do within your tests by essentially pulling this manager in into your test code. What are some advantages of Galasa? So I think it's a really interesting point to note that 80% of all enterprise testing is still manual. So where I was speaking about that testing pyramid earlier and the different levels of testing, some organizations will have these integration tests, but a lot of them, 80%, is still manual, because it's kind of difficult sometimes to actually automate these things. Imagine how much quicker you could deploy your applications if more testing was automated. And I know automated testing and sort of agile delivery are kind of traditionally seen as something only in greenfield projects, but with the introduction of Galasa, we have made it possible to be agile in a mainframe environment as well. So some of the main advantages of Galasa is extensible. So through these managers that I've been speaking about, Galasa can be extended to support all of these additional specific toolings. So we have, our managers that we've written and ship as part of the product. You can also write an application specific manager for, something specific to your organization, stuff like that. It's very extensible. Galasa is scalable, so the same test code can be run against multiple environments without actually needing to change the test. There's, as I mentioned a couple of times, the smooth integration with your pipelines. So we actually have a Galasa CLI. Again, something I'm going to demonstrate using in a little bit. So using the Galasa CLI means you can run any test, regardless of the technology in that test, from your pipelines. There's also a single point of control. So, test artifacts are centrally stored and indexed. So this can really make diagnostics a lot quicker and easier for your testing team, where there's a single point of control, a single source of truth, that sort of thing. Okay, great. So getting on to our first demonstration, I'm going to show you how you would write a Galasa test. I'm going to do some live coding, so it could get a little bit interesting here. I'm hoping it's going to go smoothly, but just bear with me if not. So as I mentioned earlier, Galasa tests are written in Java. I'm going to be writing this in the Eclipse IDE and running the testing in Eclipse after I've written it to show you how we do that. One of the main ways to interact with Galasa currently is through the Eclipse plugin. It's the typical starting point for a lot of our customers. So, if you were to get started with Galasa, this is probably one of the first activities that you would do. And also just want to note, so the test I'll be using uses something called SymBank. So SymBank is a component that we've written that essentially simulates a mainframe application. So this is kind of designed so that customers can, start to run a set of tests against SymBank, thinking in mind how you would run your tests against an actual mainframe application following this. So I'm going to have to come out the slideshow so I can go over to Eclipse. Perfect. So I'm hoping everyone can see Eclipse and see my IDE there. If no one says no, I'm going to assume that you can. So that's great. So perfect, thanks. So here we've got an empty Java test class, as you can see. Well, not even a Java test class at the moment. It's just an empty Java class. All we've got is the class name and an import and the package name. So how does this actually become a Galasa test? So we need to add the test annotation in from dev.galasa. And there we have it. It knows it's a Galasa test. It knows that it's going to be needing to run a Galasa test at the point of running this. So as mentioned, this test is going to be interacting with something we have called SymBank. And the way that the Galasa framework knows we're going to be essentially using a manager that we've written is by injecting it into the test class here with an annotation. And then we have the actual object here that we can interact with in our test. I'll import everything in later. We're also going to need something called the core manager. So again, one of these Galasa managers we have is called the core manager, and that is used, in a lot of our test cases because you can do a whole host of things. But what I'm going to need to do with it today is I'm going to use the core manager to get some credentials of mine from a configuration file I have on my laptop, because I'm going to be logging into SymBank and I don't really want to hard code my username and password into the test code for everyone to see. So I'm going to be using the core manager in a bit to pull my credentials in and use it in the test. So I'm just going to import these things in. Okay, great. And now I think the thing that will be most interesting about this so far is I'm going to be using a ZOS image for this. Now, again, I have some configuration set up on my machine that's essentially pointing to the different ports and the different services I need, but we don't really need to know about that. For the purposes of actually just writing the test, all I need to do is say that I want a ZOS image, and the Galasa framework will instantiate that and connect to it for me. So that's great. And as I mentioned earlier, I'm going to be doing some 3270 terminal interactions. So to do that, I'm going to need a terminal, and I'm going to give it the same tag of SymBank. And that is basically saying that this terminal is going to be for the ZOS image that I've tagged with SymBank as well. So give it a terminal object. Very original names. Great. And I will admit, I've got a tiny little crib sheet on my computer, and I'm going to copy and paste these other resources in, because it's not that interesting to see me sat here typing, and it's not the main thing I'm trying to show in this demonstration. But essentially for this test, I will need something that's in my resources folder, my source name resources folder. So to do that, I need this. And I'm going to be executing a web request as part of this. So I'm going to be needing this HTTP client object, which is actually provided as part of, excuse me, which is provided as part of the HTTP manager. Again, a Galasa manager that we've written to make it easy for people to do, execute web requests as part of their tests. Okay, so getting onto the actual test method that we're going to be executing. So to tell it again that this is a Galasa test method, as opposed to just a normal, Java utility method that you might have in your class, I'm going to annotate this method with test. It's probably going to throw some exceptions in here, so I'm just going to add that in just to preempt to make things easier for ourselves later. So yeah, so as I've said, this basically tells the Galasa framework to run this as a test method as opposed to just a normal method where we could need some utilities. So the first thing I'm going to do is I'm going to get those credentials from my configuration file, as I mentioned earlier, using the core manager. Manager dot get username and password. And I'm going to say I want my credentials that are tagged with SymBank. So that's the way I've set it up in my configuration file. You could have it a different way. And then I want my actual username . And my password, which we're going to use in a minute to log into the SymBank application. So this is the interesting bit of the test, which I'm hoping will be useful to kind of see, again, as a new kind of mainframer, someone that isn't, doesn't, for example, myself, I don't have a real in-depth knowledge of 3270 terminal interactions, but that's okay, because I'm going to use the 3270 terminal manager to allow me to make these interactions in a really simple way. So I'm going to have my terminal object here, and I'm hoping everyone can see, this host of methods that we have attached to that terminal object. So again, this is provided as part of the manager, and this is so I can interact with that terminal. So the first thing I'm going to do is I'm going to do a terminal. I'm going to wait for the keyboard so we don't get locked. And then I'm going to position the cursor to the field containing username. Going to do a tab, and I'm going to type in that username string that I've got from my configuration properties. Type my username in. Oh, sorry. Perfect. And then I'm going to position the cursor again to the field called password. And type my password. And I just kind of want to draw attention here to the fact that this is a really kind of chained sequence of events and a really readable kind of way to do things, which can be really helpful. So I'm going to enter, wait for my keyboard, do a P1, wait for my keyboard again. Sorry, but appreciate this. It's probably not the most interesting thing to watch, but hopefully it will be when you kind of see all the terminal screens linking together. And then what I'm doing here is, so I will have logged in by this point. This will have got me to the point of being logged into the SimBank application with my credentials. And I'm going to type bank because I want to go to the banking screen of Sim Platform. And that is it. That should have logged me into SimBank, and that should have got me to the banking application. Again, just see kind of how almost sentence-like and chained those interactions are. I don't really need to know what's going on under the covers there. I just need to know that I wanted to enter my username, enter my password, and go to SimBank. So what are we actually going to be testing here? What is probably a useful test case for, these mainframe applications? Well, it's probably going to be useful to, credit an account and see what the starting balance and the end balance is. So I'm going to go and do that. As mentioned, SimBank is sort of, a mainframe-esque application, which allows us to do these kind of things. And since I'm going to be getting the start balance and the end balance, I'm going to put this in a private method. So I'm just not repeating sort of boilerplate code. So I'm going to just take this from my little crib sheet, so you don't have to watch me creating a method. It's not the most interesting thing. Okay, great. And I want to get the balance for my account number, which is 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, 7, 8, 9. There we are. What have I done wrong here? Haven't imported big decimal. Apologies. Okay, great. So this is the method that we're going to be using to get the balance for that account number at that given time when we call this method. So I've left these comments in because, again, I'm going to show you here how we would go about retrieving that from using these terminal interactions. So again, chaining all of these commands together. And what I want to do is I want to position the cursor to the field containing account number. Oh, not back tab. And I'm going to type in my account number 1, 2, 3, 4, 5, 6, 7, 8, 9 that I passed into this method. Enter and wait for keyboard. So this should have gone and basically retrieved all of the information for that account number. But what I want to retrieve for this test is essentially the balance that we have in that account at the time. So it'd be great if I could type. So I'm going to get this in big decimal format. But to actually get that, I want to essentially retrieve the field after the field with the string balance. Again, don't need to know a lot about what's going on under the covers here, but I want to get the value that is shown on the screen after the balance field, because that will tell me what the balance is. And that's all. So our start balance should be in here after that point. Now, to actually credit the account, we're going to do a web request. I'm just going to take this from my crib sheet because, again, it's not really the thing that I kind of want to show from this, and we don't all want to sit here watching me do that. So just going to take this, put that here. And then I'm going to take my method that invokes this web request, put it down here, save some time, we'll just call exception instead. Okay, and then I'm going to call that method where I invoke my web request, passing it a hash map of parameters that I've set up here. So all these parameters are saying is this is the account number, this is the amount of 550 that we want to credit that account with. That's done all through the web request. Now, obviously, this isn't the thing that I'm showing in this demonstration, but this is making use of the HTTP manager. So again, this is a set of code that's been written by someone in Galasa that allows you to execute these web requests really easily using the HTTP manager. So great. Okay, so after we've credited the account, we then want to basically get the updated balance. So all we're going to do is call the same method that got the balance previously and get the new balance for after this point. And then finally, what are we actually testing here? We obviously want to make sure that the updated balance is the same as the original balance plus whatever we credited it with. So again, very sort of JUnit style here. So we're going to assert that the updated balance is equal to the start balance plus the amount that we credited it. And that's it. That's a whole Galasa test written there that has a whole host of things. It pulls from the core manager. It uses the terminal manager to do 3270 interactions, invokes a web request with the HTTP manager, and then we've got our test case here. Was the account actually credited with the right amount that we asked it for? So if I do a Gradle build on that, hoping Gradle's not going to be temperamental today. Oh, fantastic. Don't we just love it when we're doing a live demo and something goes wrong? It'd be great if I could see what that said. I'm not 100% sure what I've done wrong there, to be honest, but in the interest of time, because there's quite a lot of other things I want to get through today, I'm just going to take this. Should be okay. Move that out of the way. Oh, brilliant. Oh, don't we just love it? Interesting. Well, I ran this morning before and everything was fine. So I'm not 100% sure what I've done wrong.
It's always the way with live demos, isn't it?
Always the way. That's fine. What I would have liked to show you, and I will be able to show you in a different view because I ran it this morning, is after running that test, we should have got some output. Here. Great. So this is a run I did yesterday. It's, well, thought it was identical code to what I was showing you just here, but clearly not. Something's just not going right for me today. That's fine. But what I would have liked to show you is essentially here, what this is doing is, as I mentioned, it knows we're going to need SymBank. So before the test class has even started, this is the run log for our test, by the way, I should have said that. We're basically going to SymBank here, logging on with those credentials that I gave it. It's obscured my password because it knows it's confidential, and going into the banking application here. So what's really nice about, again, testing these mainframe applications and using these 3270 terminals is you can actually see a representation of what's going on all throughout your run log, which is great. So you'll see here, logged on, account numbers entered here. This was our starting balance. Somewhere through here, we credited it with that web request. This is our ending balance. And then, as you can see here, the test passed, which is great. It verified that that balance at the end was the balance at the start, which is fantastic. Now, as you saw, I didn't really add much logging or anything like that to the test. So really, this is all the output we have. But obviously, you know, in a real test, you would probably have some more things to explain what's going on. But that's essentially it. That's what I wanted to show you there for that local test that I just ran on my machine last night, obviously, that had all those different interactions using Galasa managers. So, second little demo I want to show you is how you create a Galasa test project from scratch. So obviously I have my workspace set up here, but when you go away and you want to start looking at Galasa, how do you create a test project? What's the correct structure for that so you can start writing these tests? So the way I'm going to do this is I'm going to use the Galasa CLI. So as well as having the Eclipse plugin, the other kind of way that we're, the other predominant way to interact with Galasa is through our CLI called Galasa Control. And a very new feature of that is the ability to create an example project in the correct structure that's got sort of like a sample test class. It's really easy for you to actually start writing that test code. You don't need to worry about your project structure. It's created for you. So as mentioned, this is the Galasa CLI called Galasa Control. And I'm going to take this from my crib sheet because nobody wants to see me type something in incorrectly again. And essentially, this is the command that will create you a example project. So just kind of drawing attention to a couple of the flags here. So Galasa Control, project create. We've got the features flag set to ZOS. You know, this is just for the purposes of this example, but it could be anything you like. I'm going to say that I want an OBR. That's an OSGI bundle repository. If you're not familiar with what an OBR is, that's fine. It's essentially telling the package everything that we're going to need to run this. And then I'm going to give it the package name of dev.galasa.zos.example_test. And I'm going to tell it I want some log output. So if I run that command now, as you can see, there's quite a lot of log output, essentially just confirming it's creating a project, it's creating us all these directories, these files, and here is our example project that is created for us. Now, as you can see here, it's given us the sort of main skeleton of a Galasa test class. So it's got that test annotation, as I mentioned. It's got the core manager injected into it, which, you know, as I mentioned, quite a lot of tests will use the core manager. So it's put it in there for you, and it's put in your first test method, which all this test method is doing is basically making sure that the core manager was instantiated correctly, so it won't be null. That's all that this does. And obviously what this is designed to do is allow you to just go away, extend this and start writing your first test cases, basically. We've also got an extended version of the class here. It basically just it's just injected in a few more things for you. So the artifacts manager, a resources object, and the run name. So you can basically access the run name of the test in the test. Could be useful if you want to name things with the test name as a prefix, something like that. And again, just some example sort of test methods that we can use down here and start to build upon to write your first Galasa test. So that was obviously a much shorter demo, just showing you that, you know, when you go away, start writing Galasa tests, you can use Galasa Control, the Galasa CLI, to set up that first test project for you. This is a really new feature of Galasa. It's something that was released in our last release a few weeks ago. It's going to be, you know, getting enhanced and added to as time goes on, but, you know, it's all there ready for you to start, you know, experimenting with. So, you know, don't let that hold you back, basically. Okay, so getting back to the slides. Sorry. Great. So those demonstrations I just showed you there, well, the first demonstration mostly was how to run a local Galasa test. So there are quite a few different levels to Galasa tests and different ways you can run them. So locally, that was running on my workstation, well, last night, that was running on my local workstation. And local is great. Local is, where all of our customers, most of our customers start. It's where people start to play with Galasa and understand what it's about. You can have local tests, obviously, that kind of connect to your actual applications. So local is great, but there are a few limitations to taking a local only approach. So for example, those configuration settings that I mentioned a few times, where my username, my password were, also the configuration to connect to SIM-Bank, the port numbers, all that sort of stuff, those configuration settings, they are just mine on my machine. They can't be shared across a team, for example. So that is a limitation to the local approach. Also, tests can't run headlessly. So, my workstation would have to be kept active throughout a test run. There's also, limitations to the scaling capabilities. Of course, your scaling capabilities are going to be limited by your workstation resources as you have them. So moving on to sort of the next way up in, I guess, the levels to run Galasa. So you can run Galasa in something called a Galasa ecosystem. And what that means, to summarize what that means, a Galasa ecosystem is essentially a set of microservices, Kubernetes microservices. And what that allows you to do is run testing away from your workstation. So the reason that this is really beneficial, especially when you're kind of, okay, you've written some Galasa tests, you've run them against your applications. Now you want to start actually automating these, sharing stuff across your testing team. The ecosystem is brilliant for that. So a few reasons why. So obviously you can scale horizontally. The number of tests that you can run in parallel in an ecosystem is, a lot larger, and you can run all those tests in parallel to shorten that time frame. Reusability, for example, so those configuration settings, they can be shared across your team in something called the configuration property store, the CPS. So all of those things that I mentioned, the ways in which that you kind of hook up to your ZOS images, that's all shared in one central place for your team. That's also really good if you need to make an update to that. It doesn't need to be updated across your whole team's, everyone's machines. It's a single sort of point of truth. So one place to keep a track of everything. Again, enabling this kind of sharing across teams. And also in an ecosystem, you've got more of a sort of testing as a service. So with an established Galasa ecosystem, you can run your tests on demand as part of your pipeline. We, do this ourselves in the Galasa team. We have our Galasa tests for Galasa running as part of the pipeline in our Galasa production ecosystem. So, none of the team have to worry about their workstation being active. None of us even have to worry about even having all of the test code on our machines. It's all, in a test catalog in the ecosystem, ready to be called upon for that testing. So this is the third demo. It's the last demonstration I'm going to do. This is again using the Galasa CLI, Galasa control, and I'm going to show you how you get a portfolio of tests from a test catalog, and then how you submit those tests to the ecosystem to run in automation. So I'll have to come out my slides to do this again. So just going to delete this example project because we don't really need it anymore. And what I'm going to do is take this command, which is going to prepare us a portfolio of tests. So from something called the test catalog, which I'm not going to get into it too much in this presentation, but it's part of our ecosystem. It's a portfolio of tests that we have set up there. So that's all done. So what that command is basically has done is got all the portfolio of tests from our test catalog, and it's put them in this YAML file here. So these are all of our tests from our test catalog. So I don't want to run all of these, of course. So what I'm going to do is just simply comment out everything apart from this one test here. These all would run in parallel if I submitted them to the ecosystem at the same time, but in the interest of time, it's not really most important for me to do that. So I'm going to comment all of those out, and I'm going to submit just this one test here to the ecosystem to run in automation. So again, using the Galasa CLI to do this. So I'm going to say Galasa control run submit. I'm going to give it the bootstrap for our production ecosystem, and then I'm going to give it that test portfolio there and say, submit that test, please. So as you can see there, you've got this login output, and it's telling you that run, it's given it the run ID of C23873. That's been submitted to the ecosystem. So what that will be doing right now under the covers is essentially a Kubernetes pod will be started, which will be running that test inside it. Now I'm going to go over to Eclipse, and I'm going to switch my workstation over to my normal day-to-day Eclipse workspace, because in this workspace, I'm actually connected to our production Galasa ecosystem. So what we should be able to see once I initialize the framework, what we should be able to see is actually that test run here in the ecosystem running. And as you can see, you've got a whole host of runs here that those are runs that have been submitted to automation from anyone that's connected to our ecosystem. So again, this kind of going back to that point of sharing your testing as a service between teams, you can all see all of the tests that are running at any given time. And then here, again, this is where the result would be. So this is a run that obviously my user, Jade Carino, set off, but I could see, a whole host of test runs. And these are all runs that are coming from the ecosystem. These are our regression tests that ran this morning, for example. And I can see that from the Eclipse plugin through the ecosystem. So again, getting here, it's a similar view to what I showed you in my previous Eclipse workspace for the test that I was demonstrating. You've got your run log, you've got your stored artifacts. Don't need to go too much into what these are, but this is really important for when you start running your tests in automation, that all of your team will be able to access these runs. Where if there's a failure, this test did pass, but if there's a failure, okay, how do you, everyone is able to see all of those resources that should be able to help you diagnose that failure from the ecosystem. Okay. Now, just want to keep going on in the interest of time. So I just demonstrated two different ways and two different levels of running a Galasa test, so locally and in the ecosystem. So how are our customers currently using Galasa? We've got customers at different points in their adoption journeys, a mix of internal IBM customers and external customers. What are they doing currently with Galasa? So we have customers who are at the stage of running local Galasa tests that connect to their systems. We've got customers that have installed full Galasa ecosystems of their own to start running Galasa tests in automation. We've also got customers that have extended Galasa themselves to write application-specific managers. So something that we didn't offer in a manager that they needed specifically for their organization. They've gone away, extended Galasa, and they've actually contributed that code back to the project. Customers that have successfully automated their testing with Galasa note that this has helped them achieve that sort of shift left approach to their testing, so helps them identify their defects and their regressions a lot quicker. Just want to draw attention to this quickly. So we actually released version 0.25.0 of Galasa in January a few weeks ago. I released that using our new CI/CD pipelines. So we've got a lot of new capability that was released in that. Most specifically, want to draw attention to that we now have color support for 3270 application streams. We've got a lot of improvements and additions to the Galasa CLI. So that Galasa control project create command that I mentioned, a new addition to the CLI. A few bug fixes. We had enhancements to the VTP manager, that's for IBM WASI virtual test platform, enhancements to the artifact manager, and we upgraded some of our dependencies to other open source software. So just wanted to note we've got a brand new minor version of Galasa out that came out a couple of weeks ago. Okay, so I'm hoping from this presentation that you will have liked what you've seen and, starting to think about, using Galasa to help you test on the mainframe easily and help automate some of your testing in your organization. So how actually can you start to use Galasa? Where can you get your hands on it? So being an open source project, all of our code is available on GitHub. So you can go to GitHub, view and clone the source code on the Galasa-dev organization. You can download the Eclipse plugin. So, a lot of my demonstration today was shown in Eclipse. If you go away to Eclipse Marketplace or p2.galasa.dev, you can download that Eclipse plugin and install it into your Eclipse workspace and start using it that way. You can also download the Galasa CLI. So again, this will be, the binaries for this are on our GitHub, on the URL on the screen. So you can, download the Galasa CLI, Galasa control, start using that. We also have a supported offering of Galasa called IBM Distribution for Galasa. This is a zipped distribution of Galasa. It's sort of a packaged and supported offering we have. And the zip distribution essentially allows users who, if you don't have access to Maven Central or Eclipse Marketplace or Docker Hub, if you have sort of restricted access on your company network, you can download the zip distribution and use Galasa from that point. Obviously, if you don't have restricted access, then you can use any of the options on the screen. So, as I showed, Galasa is predominantly controlled through the Eclipse plugin that provides that SymBank application that I was using in my demo. The Eclipse launchers to run a local test. You can also see the tests through the ecosystem, as I showed in my other demonstration. However, in the future, we actually do have a focus to move, focus on the Galasa CLI with more of a sort of bring your own IDE approach. We want to maybe try and decouple from Eclipse so people can use whatever IDE they are comfortable with. Get involved as well. So we're an open source project. So, customers, clients, you're free to use and also contribute back to the project. We've already seen customers contribute bug fixes and enhancements to the code base. You can even, if you don't want to contribute code, you can even just raise an issue or raise an enhancement for us on our GitHub repository. And of course, that open framework allows a manager to be created to extend Galasa with any tool that you might want to use in your organization. So, if you do start to have a look at Galasa and you realize there's something you think should be added, then please do get involved. We really encourage that. Okay, so just to wrap up, as we spoke about quite a bit during the first half of the presentation, integration testing on the mainframe is difficult, can be difficult if you're a new mainframer. However, Galasa is an open source solution that you can use to help to test easily on the mainframe without needing to be an expert. So using the Galasa managers that abstract that complex logic away from you. Galasa can also help to automate your testing, hopefully allowing you to ship your applications a lot quicker. So I guess I want to make sure we have the last 10 minutes for questions, but I want to leave a couple of questions maybe in your minds, so you can go away and start thinking about them. What would be the first test that you would write with Galasa? What is the first local test that you would start to write using Galasa? And how could Galasa help you to change the way you do testing in your organization? Thank you very much for listening, and yeah, if we have any questions, I'd be happy to take them now. Thanks.
Perfect. Thank you, Jade. That was really good. Yeah, it's not easy when you do live demos, is it? Because it goes all the time, as I've experienced myself as well. There are a few questions in chat. The first one being, if you want me to read it to you,
Yeah.
it appears you are writing a program to initiate actions on the mainframe application. I can imagine these Java programs can become large and complex.
Yeah.
Is this a sustainable approach for a long-term testing strategy?
That's an interesting question. I guess, of course, what I was showing today was one interaction for one purpose of testing on the mainframe. I mean, like I said, and like I showed in that third demo, we have a whole host of tests that do a lot of mainframe-esque sort of interactions, but obviously we've kind of encapsulated them into different classes for different reasons. Of course, I think it's more of a question of keeping your testing up to date, keeping it relevant with what you're trying to test. But yes, I guess with it being a sustainable solution, I guess if you're kind of sticking to those best practices of not having a massive test class for everything, having different classes and different projects for testing different things, then it will kind of help you to keep things up to date and keep things relevant to what you're trying to test in your application. I'm hoping that answers your question there.
Perfect, thank you. And then we do have another question as well, which is Galasa dependent on a 3270 emulator like IBM Percom, or is this the TN3270 functionality included directly in Galasa?
Yeah, sure. So thanks for your question. So yeah, you don't need to have an emulator either installed on your workstation or not. You don't need that. Galasa can do those interactions for you through the 3270 manager. So yeah, you can go away and use that manager and you don't need an emulator.
Perfect. Is there any more questions in chat? We do have 5 minutes or so for any more that you'd like to ask Jade before we wrap up. That looks like we've can we use parts of Galasa in other projects?
Yeah, absolutely. So I think that's one of the really great things about it being an open source project. As I mentioned, you can go and, clone the source code directly from GitHub and use those features kind of where you see fit, I guess. So yeah, I think, one of the great things about it being open source is you can take those bits that you might find useful and use them. Yeah.
Perfect. Thank you, Jade. If there's any more questions, please put them in chat. But otherwise, we'll wrap up. Can I ask everyone to please fill out the session feedback? I'm going to paste the link in chat. This is session 6G. Obviously, feedback helps to develop our presenters, and I know from my own sessions that I really appreciate any feedback that I get. So I'm sure Jade will welcome any at all. But thank you so much, Jade. That was a really informative presentation. And yeah.
Thanks, Lewis.
No worries.
All right, and thanks everyone for listening.
So I'll end the session now. I think there's a break now slightly, and I think the next session is at 12, I believe. So thank you, everyone.